Now, dear students, it's time to move towards some advanced topics. We have seen now that while designing the schematic in schematic editor, let me show you. We have designed the schematic in the schematic editor and we have used symbols. While if we move towards the PCB side in the PCB editor, then we have used footprints. Over here we have used the footprints. While designing the schematic we have used symbols, and while designing the PCB side of the schematic we have used footprints. So we have seen that the symbols and footprints are organized in the libraries. We have chosen all these symbols in the schematic editor from the symbol library and have used footprints from the footprint library. So KiCad keeps tracks of the user symbols libraries, and KiCad keeps a track of user symbol libraries and footprint libraries in the symbol libraries table and footprint libraries table. Each library table is a list of library name and the location of where each library exists on the disk. You can see over here, let me show you. If I move towards the project window on the preferences and click on manage symbol library, you will see over here that these are all the library names that are over here, and the next field is the library path. Similarly, these are for symbol libraries, and if we go towards the preference in the manage footprint library, over here you will see the nickname or the name of the libraries of the footprint library along with the library path. So you can even add more footprint libraries by clicking over here, and over here you can write the name. Over here you can even choose the path where your library is present. Let's delete this and cancel it. Similarly, if you want to add for the symbol library, you can also add more symbol library by clicking over here and writing the name and giving the path of the symbol libraries. In this way you can add more symbol library. Let's just delete this and cancel it. This is one way to view the symbols library and footprint library table from the project manager side. But if you want to see from the schematic side, if you open schematic editor, you can go over here preferences, manage symbol library, and again you can see a list of all the symbol libraries along with the library path. And if you want to see for footprint library, go towards the preferences. I think I have to first of all close this one in order to open another dialog box. Go to footprint library, preferences, manage footprint library. In this way you can see also see the list of all the footprint libraries. On the top side you can see there are global libraries and project specific libraries. Similarly, if you see for the symbol libraries in the schematic editor, go to preference, manage symbol library, and you can also see over here there are global libraries. These are all the list of global libraries, and these are project specific libraries. So what is actually the difference between them? Symbols are the footprint symbols and footprint added to global tables are available to all projects. Over here these are available to all the projects, while symbol and footprints in the project specific tables over here are available only to the specific projects. So user can add their own libraries to the global library table or project specific library. So in the coming videos we are going to make our own library, make our own custom symbol, as well as we are going to design our own custom footprint. Now, dear students, we are going to design our custom symbol. So for doing that, we need KiCad has a very great tool for designing your symbols, that is symbol editor over here. Under the schematic you see over here, this is a symbol editor tool. Simply click on this, and this will open up the symbol editor. This is our symbol editor. This is one way to open this tool. Let me show you another way. Let me close this. And the second way is, let's first of all open the schematic editor. For opening the schematic editor, KiCad has a requirement that you should have some project, a project running in your project manager. So let's open the project. We were doing work on this get started. So let's just double click it, and we have opened the project. And let's open this KiCad schematic. And in the KiCad schematic, on the top toolbar you see over here this button, create, delete and edit symbols. Simply click on this. This will also open the symbol editor for drawing the your custom symbols. So let me just close this also, and let's close this project. And now let's start our work by going to this symbol editor. So this is our front look of the symbol editor. On the left side in this pane you can see over here, these are list of all the libraries that KiCad offers us. The first thing while designing the symbol is, first of all you have to create your own library. For creating your own library, the thing is you have to go to file and click on this new library and choose your location wherever you want to choose your location. So let's name this library as get underscore started. After writing the name of your library, hit save. Now you will see on the left side that we have created our library get started. If we click on this, you see that there are no components, no symbols added in this library. That if I click on this FPGA Xilinx library, and you can see over here, these are all the symbol libraries that are present, symbols that are present in this library. So over here we have to now add new symbol. First of all, for our easiness, let me pin this on the top by right click and pin library. So this will always remain on the top whenever we will be opening our symbol editor. So in this get started library, we have to add new symbol. In order to add new symbol, over here right click on this, you can go over here and click this new symbol or hit N on your keypad. So let's click on this. So it asks for symbol name. Let me show you the symbol for which we are going to design is this switch. You can see over here in the DG key. This is the part number of the switch for which we are going to design our symbol. And I have opened the data sheet over here, which says, if you scroll down, this is a single pole single throw switch, and that has the model name M201, and this is the symbol shown over here. So we will be consulting this data sheet for even designing our symbol as well as our footprint. So let's just we want to KiCad asks us for a symbol name. So the symbol name is we can say it as single pole single throw underscore switch underscore nkk, and you can also add this part number at the end of this name by adding underscore and pasting this part number. The next thing, it also derive from existing symbols default reference designator. As this is a switch, then we will be using SW. Number of units per package we are going to design our symbol in a single unit, so it will be one. So keep the remaining settings as it is and hit OK. You can see over here that we have added symbol into our library. So let me just select this, hit M to move this on the side, hit M, and let's move on the side. And on the left side in the get started library, you can see that we have added our symbol, single pole symbol, single throw switch, and with the part number this one. So you see a little static star with the library and symbol, which means that we haven't saved our work. So make sure to save your work. Click by clicking on this button, save all changes. Now dear students, till now we have added our first library with the name get started and have added a symbol in this library. Now it's time to add some pins and some graphics in our symbol. The first thing you need to do is on the left side you might have mils measurement selected or inch selected. I am going to choose millimeter for my easiness. So the next step is to add the pins. Simply on the right side of the right side toolbar, go over here, click add pin or hit P on your keyboard. Let's open this, and this will open up the pin properties. The first thing it asks is the pin name. Let's say I am going to add it as pin name as A, and pin number let's say 2. I am writing this pin number 2 because if you see over here in the data sheet, its pin number starts from 2 and the second pin is pin number 3. That's why I am going to add pin number 2 over here. And electrical type is passive for the switch. And the next thing is position and orientation. Leave all things as it is and hit OK. And now you have this pin in your hand. You can place it anywhere on your symbol editor sheet. So let's just click over here. Now you have placed one pin over here, and let's leave this tool. Now if you want to do something with this pin to change any characteristics or properties, simply click on this and right click on this and go to properties. You can also hit E on your keyboard to open up the property dialog box. Click on this and this will open up the property dialog box. Now let's say I am going to position this pin at minus 5.08 mm on the x-axis. First of all, let me tell you that this cross is the origin, that here at this cross is x is 0 and y is 0, and let's choose y position as 0 and let's hit OK. The KiCad will automatically place these components, the pin on the location we have just set. Now the next thing is to add the pin number 3. As you see over here, the next pin is pin number 3. So for that you can click insert on your keyboard and this will add the pin number 3 over here. Or if you don't want to do this, let me delete this. Again go to this add pin tool, and if you click over here, let's say it's B and pin number 3 and hit OK. This is one way to do that. So let's just hit escape and press insert. Let's just add from over here B and pin number 3. Electrical type is passive. X and Y orientation we will decide it later. Orientation, let me choose it for left, so that when we route the in the schematic the wires with this, the wire should be attached with this circle, and hit OK. And now we have this pin in our hand. So let's just place it over here. Now we have added 2 pins in this. So now I can also edit the properties of this pin number 3 by clicking on this and hitting E on the keyboard. This will open up its property dialog box, and I want to position it's already on 508 and Y position on 0. So you can by editing its property you can change its settings, whichever settings you want to set for the pins, and hit OK. Now with the pins placed, we have to use circles and lines to draw something like over here a circle and some line that must indicate that it's a switch, single pole single throw switch. So for doing that, for drawing the graphical lines, let's switch to finer grid. For switching to finer grid, you can click over here on the canvas and go to grid, and you can choose like something. Let's choose this one. So we have changed our grid. You can see on this bottom side that's the grid will be 0.0254 mm, which we have selected now. So let's add some circle on the right side. You see over here these are a circle. Click on this and let's add circle over here, and let's just add over here. Hit escape. Let me move out of this line like this. Similarly, let's click on the circle and copy, Control C, Control V, and I have to place this circle over here. So we have added 2 circles. The next step is to add a line to indicate that it's some sort of a switch. So click on this add graphic line, and let's click over here, and I think it is sufficient till here, and over here right click and finish drawing. Let's just select this and move a little over here. I think this one looks nice. So now we have designed our switch by adding the graphical lines as well as graphical circles to indicate that it's a switch, single pole single throw switch. So let's just right click and go to grid and change our grid to, let me right click on this, go to grid, and let's change to 50 mils. Let's just change our mils measurement, go to grid, and over here you see 50 mils. Click on this. Now we have changed our grid to 50 mils because mostly the components in the KiCad are designed with the 50 mil grid, because if we have 50 mil grid, then we can easily connect wires with this symbol pins that we have now added. Pins which are not aligned to a 50 mil grid will not be able to wire in the schematic. This is just some sort of requirement by the KiCad. Now edit properties of the symbol. For that, go over here. This is the symbol property. Let me close this. If I click on this pin and hit E, this is the pin property. And if I click over here on this display symbol property dialog box, this is the property that is associated with the entire symbol. So over here The reference designator we have chosen is SW. For value, we are going to add its part number over here and control paste. Footprint we will design in the coming videos. Currently we don't attach any footprint with this. And over here in the keyword we can write over here single pole, single throw switch, and that is toggle switch. And the further thing, let's just hide the pin name because it looks little messy on the symbol. The symbol should look quite simpler. And now click OK, and now you see that our value is added on the symbol, as well as our A and B is not displaying on the symbol. So let's just click on this value, hit M to move it a little down. You can also hide this by going to over here on the symbol properties and uncheck this box and hit OK, and this will appear hidden when you are going to add the symbol in the schematic. So let's make sure to save all changes. So this is how you are going to design your symbol in symbol editor of KiCad. So let's say if I want to add this symbol in my schematic, let's minimize this and let's open our project. We have already worked on this. Get started, open this schematic editor and simply go to add symbol. And over here you can see that we have already pinned our library, and it has a symbol of single pole single three switch, and you can also view your symbol over here. So let's just add by hitting OK, and now you can see that we have symbol in head. Similarly, like if you can click on this, hit M, you can move, you can even make a copy of this symbol. Everything you can do with the symbols that are provided by default in the KiCad, you can do with this user custom defined symbols we have just designed in this video. Now dear student, till now we have designed our symbol for our toggle switch. Now it's time to switch our attention towards designing the footprint for that switch. For doing that, we have a footprint editor in our KiCad. So in this project manager, you can simply head towards the footprint editor by clicking on this footprint editor tool, and this will launch the footprint editor. So this is our front look of the footprint editor. This is one way to launch our footprint editor from the project manager. The other method is simply close this, and you can head towards the project PCB and just wait till it loads the PCB editor. This is our PCB editor. On the top toolbar you can see over here create, delete and edit footprints. Click on this, and this will open up the footprint editor. Either way, this serves the same purpose. So let's just close this PCB editor and close our projects, and let's add click on this footprint editor to launch this editor. So this is our front look of the footprint editor. On the left side pane you can see over here that these are all the list of footprint libraries that we have in our KiCad. And on the left side of this library pane, right side of this library pane, you can see all the display options. On the very right side is the appearance, layers, objects, and these are all the stuff over here. In order to design your own footprint, the first thing you need to do is to create your footprint library. For doing that, go to file and click on the new library, and let's name this new library as get started, and this is now for footprint. Previously we have done it for symbols, so just name it get started footprint and save. It's just taking time to update the footprint libraries. Now you can see that on the left side we have this get started footprint, and you can currently see that there are no footprint added in this library, but other all have footprints. Like if I click on this heatsink drop down, you can see over here, if I double click on this, this will open up the footprint for this particular footprints. So over here on the get started, you see that I don't have any footprints. So simply click on this get started footprint, right click on this, and click on this new footprint or hit Control N. So over here enter the footprint name. Let's say we have a switch that is toggle, and that is single pole single throw, and is of manufacturer NKK, and have part number M2011S3A1, and just and the footprint type is through hole. Click on this through hole and hit OK. Now you can see on the left side we have added footprint in the footprint library with the name get started footprint. So dear students, till now we have created our first library and added the footprint name into our library. Now for the next process, we will be constantly consulting with the datasheet of the switch. For that, that is because we have to check the actual dimensions of the pad that is required, so that the pins of the switch can insert into that pad easily. For that, let's just see the data sheet. As you see that the switch has two pin number, that is 2 and 3, and if you consult with the actual dimension, the physical dimensions of the switch, you scroll down and you will see over here that the spacing between the two pins is 4.7 mm for each type of the switches. It's a single pole. For single pole it is 4.7 mm, and that is the pitch between the two pins. Then for ease of placement, we have to adjust the grid so that it matches the pad spacing. Over here you can see, let me just move a little side, and this one also over here. So as both the pins are 4.7 mm apart, so let's just adjust our grid so that we can easily place our component. For that, you can change the grid by going to view. In this view, this will open up the grid properties, and over here you can change user defined grid for X, size of X and size of Y, and hit OK. The second way is to go over here on the top toolbar, click on this and click this edit user grid, and this will open up the grid settings. Then over here you have to choose 4.7 mm, and similarly for Y 4.7 mm, and then hit OK. And after doing that, on the top toolbar, go over here and you see over here user grid 4.7 mm. You have to then choose this grid for adding your pads. So by convention through hole footprints have pin number 1 located over here at the origin 00 and oriented with the pin 1 in the top left. Whatever the component we have, its pin number 1 should be on the origin, and while the remaining pins should be on the right side of the origin. As this switch do not have pin number 1, so we will be starting by adding pin number 2 at the pad number 2. For doing that, for adding the pad, let me just select this and hit M to move it on the side. Now for adding pad, what we need to do, that on the right side over here you see add pad tool, click on this and you can see we have a pad in our hand. And you can see, let's just escape and let me show you in the data sheet that if our switch had pin number 1, then the first pin should be on the 00 and the second pin should be on at a distance of 4.7 mm apart. So you can see over here, this is our origin and the next snap to grid is at 4.7 mm apart. So click on this add pad tool and this is our origin. The next place is over here, the 4.7 mm apart from the origin. And if pin number 2 is over here, let's just hit escape and click on this pin number 1, right click over here and go to properties, and in the properties over here, as our pad type is through hole and pad number is not 1, it's 2, so let's write over here it's 2. And for position, you see over here it's at 4.7 mm in Y. In KiCad we have positive Y direction toward downwards and a negative Y direction upwards. So over here you can see we have added the X and Y position of our footprints and choose pad shape as circular. Now the next thing that is very critical, that is the hole shape. If you check data sheet and let's just scroll down to see the dimensions of the pin that is going to be inserted into the PCB, over here we just approaching it. M2011 over, where is that? I just missed this. Over here you can see these are the pins that have to be inserted into the PCB. These have a width of 1.17 mm and thickness of 0.8 mm. So if we have a circular pad, then our diagonal maximum pin dimension would be of 1.42 mm. So in the hole size, the diameter should be 1.42 mm, but with the addition of some space so that we can insert a pin into this easily. So 1.42 mm plus 0.2 mm, and this will come out 1.6 mm. If I hit OK, you will see warning, pad holes will leave no copper. Oh, hit edit. Now the next thing you can see over here, it's 1.62, and the next thing is the diameter of the shape, the total pad. that is the diameter of hole plus the annular ring. The annular ring, let's say I want to have a width of annular ring that is 0.15, and on both the side of diameter that would be 2 into 0.15. Now let's hit OK. Now it will not, the warning will not pop up. That was saying that the hole is greater than the annular ring. Now we have just corrected by adding the correct dimensions and hit E. Now you can see that we have added pad number is 2, x at y position, total diameter is 1.92, including the annular ring, and 1.62 is the hole diameter where the pins of the switch will be inserted. And hit OK. Just see over here, it seems that annular rings are little are not enough wide that the switch will hold into this after soldering. The annular ring looks slightly small. The switch will be easier to solder and mechanically more robust if the annular rings are made larger. So increase the annular ring thickness by going into its properties. It is the footprint property. Select this pad, hit E, and let's increase the annular thickness by increasing the diameter. Let's say we have a hole diameter of 1.62 plus, and from 0.15 I am going to increase annular ring to 0.3 on the both sides, so it's 0.3, and now hit OK. Now this is sufficient to hold the component in place once the component is soldered and inserted and soldered into this. The next thing is let's add another pad over here. Click on this, we have third pad. This is at the location of 4.7, and this is at the next location that is 9.4. so this is 4.7, this is 9.4. click on this and hit escape. You see that when I clicked on the add pad tool, it automatically detected that it is pin number 3. So for switching, for adding the properties of pin number 2 to pin number 3, click on this pad 2, right click on this and push pad properties to other pad. Click on this. What this will do, this will automatically add the properties of pad 2 into properties of pad 3. So as both the pads are similar, so change pad on current footprint. So both the pad 2 and pad 3 have now similar same hole diameter and same pad diameter. So make sure that you save your work. In the next videos we are going to design some outlines and some graphics into our this footprint. Now dear students, till now we have added 2 pads in our footprint, and that is pad number 2 and pad number 3 that are spaced at a distance of 4.7 mm, as we have seen the distance from the data sheet. So now it's time to add some footprint graphics. A good footprint will have exact part outline drawn on fabrication layer and a slightly larger outline on silk screen layer, and a courtyard surrounding the entire footprint to prevent overlap with the other footprints. So there are 3 things that we need to draw around the footprint pads. The first thing is that the fabrication layer, we have to draw outline of the fabrication layer that actually defines the dimensions of the component. The second thing is we have to draw the outline specifying in the silk screen. The outline drawn in the silk screen will actually be shown on the PCB when we will be using this component in the PCB. Actually this with the help of the silk screen outline, we can identify the component on the PCB, as well as the designators are also written on the PCB that are all in silk screen. And the third thing, outline we should draw is in the courtyard layer. In courtyard layer, this actually prevents the overlapping of any other footprint with this footprint. So we have to add these three. So first of all, let's switch to front fabrication layer. We have to draw outline in the front fabrication layer. This front fabrication layer dimensions should exactly match with the physical dimensions. So you can use line, rectangle, line, arc, rectangle, circle, and a combination of these to make this outline. So let's first of all consult with the data sheet that what is our dimension. So this is the switch we are going to use, but it has two pins. Let's just see its dimension, that it has a length of 13 mm, and over here you can see a width of 7.9 mm. So in our footprint we need to draw something like this. If I can show you like this is just a rough thing, a boundary that has a length of 13 mm and a width of 7.9 mm. So let me just delete this, and let's be very precise while drawing the outlines, because these are the dimensions that are fed to machine while fabricating the PCB. So one way to precisely place is to set the user grid and to change the origin from this place to somewhere else. So let's just do it. For let's change the user grid by going over here and edit user grid. Over here you can choose as my X size as the width of component is 7.9 mm, that is in the X direction, and it has a length of 13 mm. So let's add this, the grid in X direction 7.9 mm and Y direction 13 mm, and let's hit OK, and let me show you. If I place over here like this is just rough one. What I need, actually my origin is over here. I want the origin to be centered with the dimension of my footprint, which means that currently my origin is over here. Next time if I want to switch my origin to the center of my physical dimensions of the component, then what I need to do is I just want to go to edit user. X and Y should X is the width of my physical dimension of my toggle switch, and Y is the length. So let's set the origin to half of total width. In this way my origin will be at the center of the x-axis. Similarly for y-axis, what I need to do is 4.7, which is the distance from this origin, from the current origin to this pad 2, and doing this minus the total length divided by 2 and hit OK. Now my origin has now shifted. So let's just delete this, and now let's draw a line from this to this. You can see over here this is 7.9 mm. So click over here, and now from over here this you can see it's 13 mm, and let's go over 7.9 and then move over here. This is again 13 mm. So let's just right click and cancel and just leave the tool. So we have drawn this boundary in the front fabrication layer, and we have just moved our you can say the region over here above this point, and have added a 7.9 mm length in the x-axis and 13 mm in the y-axis. So the next step is to add the front silk screen. Now dear students, we have added the front fabrication layer in our footprint. Make sure to save your work by clicking on save button. Now it's time to add the outline in the front silk screen. So let's just select the front silk screen, and this outline should be just outside of the part outline. This was the outline in the front fabrication layer is actually the part outline, so the silk screen lines are moved outwards from fabrication drawing by 0.11 mm, which means that the silk screen line we draw out of this will be only 0.11 mm out of the fabrication layer. So how this is done? Actually, if you see the width of this line, so click on this and hit E to edit its properties. It says line width of 0.1 mm, and similarly hit OK. And if I draw line in front silk screen and click and hit E, it says a line width of 0.12 mm. So let's just delete this. In order to do so, to draw outline in silk screen, what we have to do is we again will change our grid in the we will again change our grid by going to this drop down and clicking on the edit user grid, and over here as you can see we have to change the origin and the grid. For X grid it says we have a length of 7.9 mm, and we have to increase 0.11 mm on the left as well as on the right side. So let's just add over here +2 into 0.11, and similarly for Y we have to increase this grid snap to grid, this grid dot over here, to slightly outward equal to 0.1 mm distance. Similarly this dot or snap to grid to move it little upward of about 0.11 mm. So for doing on both the side to increase the size in y-axis, similarly what we will do, we will do +2 into 0.11. 2 means on both the sides. So in this way you have changed the grid size of X and grid size in Y. Now it's time to change the origin. As you can see we have X size grid of 8.12, so we will set the origin of half of the x-axis, and similarly we have to change the origin, to shift the origin slightly by a distance of 0.11, which we were actually we have just added in the grid size of X and grid size of Y, and then hit OK. Now you can see over here this dot have shifted little up and on the right side, which means that it is about 0.11 mm shifted from the previous grid size. So now let's just select the front silk screen, and similarly you can add over here, draw a graphic line and go over here, click on the snap to grid, click over here, it will again add 13.2 mm, click over here, click over here, and let's just click over here. And now hit cancel. Now you can see, just let's leave this tool. Now you can see we have drawn a silk screen layer, outline in the silk screen slightly out of our fabrication outline. So silk screen actually help us to identify the component boundaries on the PCB. So after drawing the silk screen, make sure to save your work. The next thing is to draw the courtyard outline. Now till now students, we have drawn outline in fabrication layer as well as outline in silk screen. Now the third layer we have to draw outline is the courtyard layer. It actually surrounds the part so that no other footprint can overlap with this footprint. So finally select the front courtyard layer and let's just do it, draw this outline in another way. Let's change the grid from user grid to 1 mm, and let's just add a rectangular, draw a rectangle, and you can click over here, sorry, just click over here, delete, front courtyard, draw a rectangle, click over here, then I need to click somewhere over here. So this is the courtyard of our footprint. You can also add dimensions in the rectangle by clicking on this and hit E, and by hitting E you can add start point as 4.2 and Y minus 2.05 and choose endpoint 4.2 and 11.45. These are dimensions. I have just sorted out the start point and end point by looking into dimensions of physical dimensions from the data sheet, and hit OK. Now you can see that we have very precisely outlined the courtyard of our footprint. So these are the three layers that three outlines in three different layers that a component should have. The first one is the fabrication layers, and that we have just added over here. In the fabrication layer we have drawn the outline that specifies the machine to tell that this is the actual physical outline of the component. The second one is the silk screen. This white line we have drawn between both the lines is the line that actually when a PCB is manufactured, you can see that the outline on the PCB. And the third one is the courtyard layer that specifies the boundary of the PCB of the footprint so that no other footprint can overlap over here. So make sure to save your work. Now our footprint is complete. Let's see our footprint in 3D viewer. Go to view and 3D viewer. So this is our footprint. You can see over here. Let's just close this and let's move this a little over here. Similarly, you can edit footprint properties, and you can add reference designator as SW, and you can change the value to only the part number. In the description, in the keyword, you can add single pole single throw, toggle switch TCH, and hit OK. So we have also changed the text values, and the footprint is now complete. So let's try to use this footprint in our PCB. Let's say if I go to my project file, open project, and this was the project we were working with. Let's open the PCB. And this is our PCB we have just developed in the previous sections. Let's add a footprint, and let's search for get started. Okay, this one. So you can see over we have footprint shown over here in the preview window. Just hit OK, and you can place it over here, and you can use them. Now, dear students, till now we have designed our footprint of single pole single throw switch in our footprint editor, as well as we have also drawn symbol for our switch in the symbol editor. Now it's time to use the symbol as well as the footprint. So let me just close this and close this footprint editor as well. We have been working on this project with the name get started. So let's just open the schematic. In the schematic, let's add a switch between the battery and the load. So let's just click on this wire and delete it, and let's add symbol. So over here we have this one symbol. So let's just double click it, place it over here, and let's add wire. We're going to add wire tool, and let's connect this. Let's connect towards this. Now you can see we have used our symbol which we have designed in symbol editor in our schematic. So let's click on this and assign footprint to this, and let's assign the footprint we have just designed. So this was the footprint we have just designed in the footprint editor. Let's just double click it and hit OK, and let's check for design rule errors, electrical rule checker over here. Let's perform this and see if we have any errors or not. Run ERC, and it has one warning that says power hidden pin VCC power input line. So let's just click over here, control copy and control V, and place it over here. Hopefully this will solve our error. Let's again run the perform electrical rule checker, delete our marker, run ERC. Now you can see that we have no errors and warnings. Run again, no errors and warnings. So let's just close this and let's just save our work. Now it's time to switch our attention towards the PCB side. Let's minimize it and open the PCB in PCB editor. Let's just double click it and it will load the PCB editor. So this is our PCB, but we see that we have no place, or we don't see the switch being added over here. Now we have discussed in the previous section that we have to manually update our PCB. For updating our PCB, you have to go over here, update PCB tool, click on this, and let's click on this update PCB. It has no errors, and let's close. You can see over here these components need to be placed over here, and because this is the component that was not used, so if you click over here and place this component, and now let's for a while just hide the copper zone. And now as you can see, these are our previously drawn tracks, which currently we do not need to use them because we are going to replace them with the switch. So let's just delete them, delete this via, as well as drill this stack, this little track, and now you can see over here that we have switch placed over here. So let's just click on the resistor, hit D to drag our resistor a little toward this side, click on this toggle switch, and let's move over here. So let's add track by using add route track tool. Click over here and let's add track over here. Similarly, let's connect with this, and now connection is made. We have a little extra wire track we have mistakenly drawn. Let's just delete it. And now let's show field zone. You can see that it will generate error when we will be using DRC. So let's hit B on the keyboard to refill the zone. So you can see that our zone is now refilled, and let's check for the design rule checker if it gives any error or not. Run DRC. It has no error and warning. Let's just close this and let's view our PCB in 3D viewer, how our switch will look like. So you can see this is our footprint for our switch, which we have designed. You can see the bottom view of your PCB. So in this way we design our symbols in symbol editor and use those symbols in the schematic editor, and we design footprints in the footprint editor and use those footprints in the PCB editor of the KiCad. Now dear students, let's discuss something about the 3D models. Let me show you. This is our PCB we have just designed in our previous section. Let's just wait till it loads. So let's check in 3D viewer. If you go to 3D viewer, you can see over here this is the LED and this is the resistor. These are actually the 3D models that are attached with the footprint. Similarly, this is the battery that has the 3D model that is attached with the footprint. So how we can attach the 3D model with this switch? So let me show you. Let me close this and let's open footprint editor. So 3D models for components are stored in a separate file names for components. 3D models are saved in a footprints. Any number of 3D models can be added to each footprint. 3D models file name along with model scale, rotation, offset, and opacity are set in 3D model tab of the footprint. So where you will get this, this is the actually footprint we have just designed by clicking over here, edit footprint properties, and as we have just used the general settings, but we haven't studied about the 3D models. So these are here you can add your 3D model. If you have the files of the 3D models, you can simply click on this and click over here and add the path for your 3D models. You can even scale, rotate, and give offset and change the opacity. So the 3D models, both dot step and VRML 3D model formats are supported in the KiCad. Step files are useful where dimensional accuracy is needed, while VRML files can be used for more visually attractive renders. You can see that if let me show you if any other component. Let's click this capacitor. This is some capacitor. Let's go to its properties, and you can see that this is the 3D model that is attached with this footprint. You can see this is the 3D model attached with the footprints. You can even design your own in using FreeCAD tool or Blender, uh, and attach them with the footprints. Let's say if I choose some LEDs, let's choose LED, and let's see, it also have 3D models attached with this footprint. So this is the 3D model of the LED. Similarly, you can also have a 3D model for your custom footprint that you have built. Over here, simply you go into properties and add 3D model. You can even design your own 3D model in FreeCAD or Blender and then add those files over here, and that 3D model will appear on this PCB. You can even scale them, rotate them, and offset them. This is how you can add 3D model to your footprints.